All right, testing levels and stuff. I'll actually go live for real in 15 minutes, but I'm just testing that everything works. Levels and stuff. I'll actually go live for real in 15 minutes. I'll talk so that we can check audio levels, and I'll try going over here to switch cameras. Ooh, we have someone in the chat already. I feel real. Greg, you are real. Greg, you're from the future. Let's switch over to that camera. I have taped out a section on my workbench so that I don't do stuff outside of there today. And I know this is the blind spot where the picture-in-picture is. And I even made notes for what I think I'm going to do. Oh, let me switch to that view. And I'll squeeze this over a little bit. I need a third monitor. That's probably what I need. Can I put chat down here? Oh, I can put chat down here. Hey. No, tech guy, I'm just starting. You did not miss it. Oh, thanks, Scott. It sounded good. Okay, I know I'm answering things you wrote minutes ago. I'm going to put chat for YouTube over here. If I can. Oh, let's pop off the chat. Does that work? No, not when you're the one streaming. Hey, Stuart. Thanks for coming. I know I didn't give much advance warning, so I appreciate that you're here. Just going to watch me resize Windows for a moment here. Okay. And Twitch chat is there. This is way more to keep track of than my brain can handle. I will mostly ignore chat for now and kind of come by in a little bit. No, so actually we're not really starting for about 10 minutes. So this is a great time to grab a snack. Awesome. Thanks, Scott, for being in the chats. So, hey, I just got back from vacation. Some of you who follow me on social media will have seen that I'm very excited to have cleaned off my workbench. Let's switch to this view here. So I have kind of two main workbenches in my shop. This one that I usually present stuff from, and this one back here, which often just collects junk as I'm clearing this off. But I cleared this bench off when I got back from vacation. I started making it messy again already, but I'm very happy about that. And I have a I have a project coming up. I'm going to be building a CNC machine back here, and then I have I'll do a lot of projects on it, but I have one project in mind that I'll talk about in the future, and not just Stuart Riggs' future or Greg's future, but future, my future too. So anyway, it's exciting to have cleared that one off. I was thinking about building another one of these, maybe not as wide, and moving it over there in the shop. But for now, I'll leave that where it is. These are actually cool workbenches. I probably should do a little thing about that, or if I build it, I'll do a time lapse. This is a workbench that comes from the Experimental Aircraft Builders Club or group or something like that. It's something a guy I used to work with hipped me to a few years ago. There's a group of people who build experimental aircraft, and at one point they all decided to have a standardized workbench based on this design so that they can, I guess, push lots of them together to make a bigger surface, and you've got standardized heights and widths, and it works out nicely. It's all pretty much, if I remember, 2x4s, and I used a solid core door as the top, but you end up making kind of 4x4s out of 2x4s put together. It's a neat design. I have a little bit of plywood at the bottom too to make a shelf that I store stuff on. But anyway, that's enough about my workbench probably for now. This one's a steel workbench that I got from a picker that I know, and then I put a maple top on it so it would look all nice for filming for videos and photography and stuff like that. A little bit nicer and more expensive surface than this solid core door, which I ought to paint at some point, but I kind of like the battle scars. So let me see, time is 9:21. That's my Metro Mini time that I'm looking at there. Let me see if that's the same as the computer time. And let's see, what types of cameras do we use for all the items on the work desk? Oh, you were seeing two of me because I have two cameras pointed at me. Here, I can switch over to this view. See, now there's just one of me. Yeah, I can see the PC, but I'm easily distracted. So if I'm talking to you, I'm probably not paying attention too closely to what I'm showing. Sorry. Yeah, my setup is, oh, can you see my belt buckle? My Captain America belt buckle? Can you see it from back here? Oh, look, I have switching back here now. Let's go to this view. You can. Yes, I have Captain America. I put that buckle onto this belt for 4th of July. I'm in no way associated with Marvel, and I'm not being paid. So this camera, you can probably kind of see it. That's just a little webcam Logitech, and I forget the model number on it. These are, it doesn't say on it, the 920C, C920, something like that. Noah and Pedro have some of these too. That's the one that was overheating on me, I think, last time, or some people say it might have just been too much data on one USB port. So I didn't change that since last time. Hopefully that won't cause any problems, but I can apparently disconnect it and reconnect it pretty quickly and get things running again. The camera that I'm talking to right now is a Sony A6300. It's a 4K mirrorless, sort of like a Micro Four Thirds sized camera. And one thing I love about it, it's got really, really good autofocus. Normally I try to just manually focus stuff. I think this one I've got manually focused so it won't be blurring in and out. But that one's got really good autofocus, so that helps me a lot since I'm shooting one-man band style here. And I'm not shooting or capturing 4K, I'm just capturing at, 1080, and I'm broadcasting 720. I'm recording a 1080 stream as well as we go. We'll see if my computer can handle that today. All right, so I think let's recap where we're at from last time. Oh, and critical thing, I just remembered, I left my iPad inside, so I'm going to go to the coming up next screen for a moment. Please talk amongst yourselves. And I'll be right back. Okay. And here we go. Okay, so I've got my iPad now. And let's recap where we were last time. So iPad, pinball arcade game, and go to my favorites here, Theater of Magic. Start. All right. So there's Theater of Magic. What we're trying to do here is avoid using the screen controls for the plunger and the flippers, and instead use this controller that has a plunger there that you can see and buttons. So let me step over to the workbench. And I'll show you what we've put together so far. So right here I've got, this is my Teensy 3.2, and I soldered it to some headers and then put some headers on this little quarter-sized permaproto board. It's a cool little Adafruit thing. And I have connected this left button to one of the pins and ground on the Teensy. And so the Teensy is, when it's plugged into USB, acting as a keyboard. It's a HID USB keyboard. So with the weirdly named USB camera adapter, USB to Lightning camera adapter from Apple, we can plug this in to the iPad, and we can press buttons that will cause the Teensy to send USB keyboard commands. So let's get a, which USB cable? Let me grab this one here. Okay, so if I plug the micro USB and into the Teensy over here, okay, this will now act as, let me head over to a notepad app for a second. This is my testing screen, as you can see. So notice I just tapped on the screen and the virtual keyboard didn't come up, and that's because it thinks there's a real keyboard connected. So when I press this button, it sends the HR sequence, which is down for H, and R for up. And that's how this iCade standard works. If you've seen the iCade little arcades you can slip your iPad in, as well as they have a couple of controllers and maybe 3-4 accessories they sell. All of them work on this premise of games that are iCade compatible are expecting some keyboard shortcuts to control the game. So HR is the left flipper. And what I did is I just went through and tested, let's see, do I have notes here? I have them up on the computer. Let me go over there. So what I did was test out which keyboard shortcut combinations would work the paddle and flippers. So here they are. You can see plunger is the XZ combo. Here we go here. So plunger is XZ, and I chose pin 1 on that. And I should mention what I'm using. I didn't have to reinvent the wheel here. What I'm using, you can see this Arduino sketch, is based on one called Teensy iCade Input by Alan Huffman. And the URL is here. If you can't see that, I'll put that into the notes for the show. And I've just gone through and made some really, really minor modifications just to map it to what I need. And I also decided to turn on the little LED on there full time so that when this thing is plugged in, I'll know that it's turned on. So far, that's working well. One of the issues with plugging things in through that Lightning USB adapter from Apple is that it really can't support much current draw. So if you plug in a full USB keyboard in there, I tried just the normal Apple alphanumeric keyboard, the full-size one, it wouldn't allow it. It said this is drawing more current than the iPad can allow. And this was true of some other microcontrollers I tried as well. So I found the Teensy works, but it's drawing 0.2 amps right now. And is that right? 0.02. The fear is that if I draw too much more with LEDs and things, I could end up freaking out the iPad and it'll reject the device. But for now, it seems to work. So I've told it to turn on the LED, and then I'm checking pins 1, 8, and 12. That's what Alan had mapped in his, so I left it alone. For plunger, left flipper, right flipper. So this Arduino sketch is up on the Teensy. Let me go over and we can now solder up the rest of the buttons and the plunger for this. So let me switch back to overhead cam. And we can, let's leave that, I'm going to leave that connected and show you here just with a little piece of wire. Switch to this view. Okay, so I'm just going to use some of this enamel or cloth covered hookup wire. I guess it's not enamel on this stuff, the wire wrap wire. Just going to take a short length of that, and I will short from ground to these other pins that I figured out I needed. So if I want right flipper, that's going to be 4. So if we and pin 4, oh, I'm sorry, no, it's actually pin 9, but I have that on the proto board's number 4. It gets a little confusing. Okay, so here I see NJ and J on that one. Is that right? Yeah, and left flipper HR. You might be able to hear that airplane going by. Okay, so now what I'll do is go ahead and solder up the rest of these buttons onto the board. So let me unplug this now. I can set the iPad aside. And let's see, do you have a pretty good view of that? Not bad. Okay, I think I'll get, well, I don't have too much extension on these, so yeah, I'll leave it at this level. I think I'll get a little helping hand tool of some kind. How about this guy? Let me use one of these just to bring this up to where we can see it, but I can still solder. Oh, in fact, the first thing I'm going to do is I'm going to bring my ground from the Teensy over to the other rail. So last time I got the ground over to this left ground rail on the board. Since I have these plunger wires and right button wires and also the LED I'm going to plug in that's built into the cabinet, over to this right side, I might as well have ground connection there. So there goes a crow. Did you hear that? Okay, so I'm going to grab a nice little piece of stranded silicone wire. And I'll just go, I'm actually going to run all the way across the board from that rail to here. So what I'll do is twist this up, tin it, and then solder that in. It still fits, right? Yeah. Ooh, look. Another hand. I really love these crazy third hand tools. Wave the solder away. Something like that works pretty well. You'll remember last time I had some problems because I got the Teensy flipped upside down. Ooh, my camera just went out. All right, let me fix that. Which one is that? Is this guy? So the good news is I have an HVAC guy coming to look at putting, oh yeah, the temperature has gone crazy on that camera. All right, let me see, do I have, let me make a new view real quick. So I've got an HVAC guy coming to help me out because my workshop is too hot, as you can see by my poor camera giving up on me there. Let's see if I can switch that input to I'll add in my FaceTime camera. Hello. All right. Yeah, so I'm going to get HVAC in here because it is too hot and fans are too loud. So yeah, so last time you remember I had my Teensy, I had it oriented improperly. So this is sort of normal expected orientation, and I was looking at everything like this. So I thought I had grounded something when I actually placed it on pin 13 there. So what I did was I made this little version in my notebook of the way I've got it oriented, wrote in all my pin numbers and what I'm connecting. This helps me a lot. Otherwise, because the Teensy is so small and there's no silk screen on top, it's easy for me to get confused. Okay, so let me solder this up, and then I'm actually going to go turn off my Sony camera so that it has a chance to cool down. And let me trim off these little extra leads. Okay, so now I've just got ground running on both sides of this board, which will make it much more convenient to plug in the right side buttons. While I'm at it, I will crop this view up. Hold on one second. I have begun to appreciate what a Wirecast wizard Phil Terone and Noam Pedro, all these guys, Lamore, have become. All right, it's a little better. Yeah, so let's go ahead and do, how about the right button? That'll be satisfying. So drop this down here. And so I said right flipper is pin 4. Again, I wish I had little connectors that I could just plug these in, but I don't have any of the female end of those that I would need, or maybe it's the male I would need. So I'm going to simply cut, strip, and solder that in place. Looks like those are 24 gauge. I've realized wire strippers are a decent way to figure out the gauge of stuff because with these ones, which are pretty precise, if you try like 22 on a 24, you don't quite pull the stripping off. So how about that for a weird improvised measurement tool? Okay, I don't think I need to tin those, so I'll go ground. And, oops. Ground and pin 4. Okay. Oh, I just lost one out of there. Yeah, these wires are so thin, the whole wire goes through the hole if you're not careful. Gotta push the insulation back up. I think I'll go ahead and plug it back in and test it out. Sometimes it's nice to test things a lot along the way instead of finding out at the end that you did one boneheaded thing, like I sometimes do. Okay, so I'll plug back into the iPad. We'll test the keyboard commands, and then I'll also test it in the pinball game. Okay, so far so good. So right button, JN, JN. HRHR. Let's see if that was right. Pinball. Yes! Oh yeah! Come on. Beautiful. All right. This is a super satisfying project, I have to tell you. Really fun. Okay, next up. So this is, by the way, this is the battery pack right here. The wire coming from the, it was 3 AAAs, I think. We're not going to use that for anything. I think I'll go ahead and get it out of the way just to avoid confusion. Oh, my game is talking to me. Theater of Magic is awesome, by the way. Has anyone played this in the arcade? It is so cool. It has a lot of great electromagnet effects where the ball leaps off the table when it gets near this one object, this like magician's trunk. It just leaps off the table and sticks to the side of it because there's some huge magnet. It's really cool. Okay, so next we have the plunger. And I discussed this last time. So the way the plunger works is super awesome. So this mechanically is, you can see I've got this spring-loaded plunger with this white rubber cushion at the end. When this is put together, that holds this button in place. And then when you pull the plunger back, it releases the button. And when it hits the end of its stroke, it compresses this back down again or closes the switch. They also used a distance sensor. That's why there's 5 wires off of here, which is super cool. So in the software that this controller was meant for, it was able to ease the plunger, the graphic plunger, in and out just as you eased the real plunger in and out. I won't be using that. That's awesome, but I won't need it. I'm not cool enough to do it. I don't know. I'm skipping that part. So what I needed to do was figure out which 2 wires here are the switch versus the 3 wires that are the distance sensor. I cheated on this. I tried it the other day. It is the white and red wire just to save you the pain of me going through and testing continuity on all those. But I can show you what that looks like just if you're curious. So again, I'm just using this super thin hookup wire, and I've got on my multimeter, I could put this into view here, I've got a continuity mode here, right? You'll have this on pretty much every multimeter, and I'll go ahead and I'll cut this end off and strip it now. Let's make it a little easier. So forget about the hookup wire, I don't need that. And so I found it to be the white and the red wire. I think I made some notes somewhere, didn't I? Yeah, red and white wires. So imagine stripping all of these and then going through systematically and testing to find continuity, or look at the board closely and you can probably figure it out as well, which would be another smart way to do it. Not the way I did it, but I instead plugged tiny little hookup wire in the end of that connector, which I realize in retrospect was not the greatest way to do it. Okay, so there you go. So you can see we press the switch and that creates continuity. So before I solder these in, no, actually I'll go solder these in, test it, and then I'll check the chat just to see if any interesting points have come up or ideas people have had or questions that aren't taken care of. Okay, so plunger I determined was pin 1 of the Teensy, and I've got that mapped to row 12 on this board. So I can go to 12 there, and ground. Let's carefully flip that over. And I'll hold that a little bit with one of these. Okay. And of course the ground one sort of fell out. There you are. Okay, that looks right. 12, which is on plunger, pin 1. And on this side of the Teensy, it's ground, pin 0, pin 1. So that looks right. White and red. Let's plug it in and give it a whirl. Ha ha! Ha ha ha! Yes! Here we go. I'll let it drop again so I can use the plunger. And yes. So you of course want to save a good reveal towards the end of your broadcast, right? So I won't use the real physical plunger yet. I've tested the switch, but the real Magilla is going to be the plunger. Okay, so this I can unplug and set aside. So let's have a look at the chat. And the wide cam is quite fast. That's good. Woot, it's alive! Yeah, Noam Pedro, I love this wire stripper, which I've had for a decade easily. But it sometimes is a little sketchy on the super thin stuff. It's just, I think, a little too violent, and it yanks stuff too hard sometimes. But I love that one for production mode of lots and lots of wire stripping. I don't know if you have a different one, but that's the one I have. Mic battery. Good idea to check. How do I sound? Do I still? Yes, I still have mic battery. I wish these packs could plug into external, especially the receiver one. There's probably some expensive adapter that Sennheiser makes for that. All right, and hello, hello. Someone there. Okay. I think we're all good. I think there's no disasters looming that you guys have noticed. All right, let's turn this big camera back on and see how it's doing. USB mode connecting. No signal. And well, I got the big camera working again. Let's see if it deals with that. you can start to see why there are a lot of people usually involved with these things, like on a TV station. It's not just one guy fiddling with stuff, but thanks for your patience. Okay, now what we've got is LED. So I will, right now I'll show you, I have pin 13, which is the onboard LED pin on the Teensy, just like a lot of Arduinos. I have, when I plug that in, you'll see it just lights up to tell me that the system is on. Right there. See that? So what I'd like to do is light up one of the onboard LED that is here on the original Pinball controller. So this actually is a, I think it's an RGB LED, or it's a two-color LED. It's a two-color LED. So they just have red and blue as well as ground. So there's 3 wires coming off here. I'm just going to make it red. I kind of prefer that. So what I need to do is plug that into pin 13 on here, which drains that one a little bit, or dims that one a little bit. I'm okay with that. The one issue I noticed, I tested this before, is that this thing is really, really bright. So I'm going to put a resistor in line to prevent that from being distracting and blinding. So again, I'm going to strip this, and all right, Noah and Pedro, this one's for you. I'll try it with my auto stripper. You can also do multiples at once with this, which sometimes is a little better for these thin wires. So ka-chung! 3 stripped wires. Boom. And let's see, you know what, I kind of like this bigger view maybe. Let's switch back to that. Okay, so let's go ground to ground, and then I'll put a resistor in line for red. I can show you first actually how bright that is. Why don't we do that live? So let's see, this is going to be plugged in here. I'll do ground right there. And let's see, do I have anywhere good? I don't have a lot of freedom on this board, actually, I realize now. So I might go ahead and attach the resistor to the wire and then just plug that into pin 13. All right, so this is a funny way to do this. So what I'll do is get some helping hands out. And I'll get some heat shrink and just make a kind of inline resistor. Move that to where you can see it better. A little harder to show stuff as it actually gets put together. Okay, so I have a little bundle of heat shrink tubes. Let's see, that one might fit. Resistor. Oh, what did I say? I said I was going to test this first without. Okay, so let's take a look at that. Let's use, I can just touch it to there and we'll see it. All right, so there's the LED. Let's plug that in up here at pin 13. Just try to hold it in place. Put a little bend in it and plug it in. Okay, so there you see, there's the LED. It is kind of distractingly bright. So I'm going to dim it by about half. I tested a couple of resistor values yesterday and decided that 4.7K was pretty good. I can tell it's on, but it's not the brightest thing in the room either. So no, there it is. There's a 4.7K resistor. So I will solder that there and then slip a little heat shrink over the thing, and this end will be what plugs into the board. Okay, just twisted those up pretty good and solder it up. And I have a heat gun that I like to use for this. It's actually a rework heat gun, but it works well for get it up to temperature. It's a bit more civilized than using a lighter or the side of your soldering iron. They all work though. All right, now you can see when I plug that resistor in line to the LED and plug it in, we get a more moderate, dimmer LED to tell us that things are on. Success. Okay, so let's see what's left. Everything is plugged in. What I'll do is route this. I'm going to mount the PCB now. Oh, let me solder that, how about? Then I'll mount the PCB. And I'm going to then need to route the USB cable, and I probably just hot glue it in place, honestly, so that I have a little bit of strain relief. And I'm going to cut a hole through the back of the battery pack here so that I have a place to run that wire out and then up to the iPad. So you can tell if this were wireless, which the original one was wireless, you have the benefit of no wires. Pretty nice. However, one thing that I like about this is that there's no connection to be made. It's a little more direct. It won't drop a connection like Bluetooth might. And I couldn't get BLE working easily as a keyboard. BLE keyboard versus Bluetooth keyboard are two different things, and I'm not sure yet, I haven't looked into it, how easy that is to get an iPad to deal with or an iOS device to deal with a BLE keyboard. And also there's no batteries necessary, right? So if I had a BLE device, I'd definitely not be able to run that all off of what, Magic Air? No, I'd need batteries. I'd need a separate battery thing. So plugging this into the iPad is kind of cool for that reason. Okay, so let's solder this. And then I think I'll go ahead and make a hole in the case. So let's unplug this for a second. Okay, what I want to do is make a hole big enough to fit that through. So what's this? Something like 12 millimeters, 13 millimeters. Hole around that size would be enough to plug this through. And let's look at the back here.
So what we have are 3 AAA, three AA slots. I'm going to put a hole right in there. And the way I'm going to do that is just with a drill and a Forstner bit, which is a little hole bore. It can be big, but I've got some littler ones. Let me grab that. Drill. There's a Forstner bit. It's about 16 millimeters. Perfect. There are probably less violent ways you could do this. Maybe score it a bunch with a knife and chisel, or use a Dremel tool, but this ought to work pretty well. You know what, I should have some safety glasses on, because I don't want a piece of hot plastic in my eyeball. Did it. All right. That would have been a smart thing to do at the very beginning of this, right? Instead of once everything's wired together. And rather than blow that all around the shop, I'm just going to sweep that into a bin. Okay, this is pretty good. I'm just going to crack off a piece of that plastic. Oh, it came out pretty nice, nicer than expected maybe. So that's where I can thread this through. And up to there. And then it'll come up out of the top and plug into the iPad. Okay, so the Teensy I put on headers partly so that I'd be able to screw this Permaproto PCB back into the little standoff for the screw where the original board was. So I'll take that off right now, carefully. Set that aside. And here was my magnet bolus of screws. I think it's one of these smaller ones for the board. Good. Doesn't fit through the hole on the PCB the wrong way. And let's put that in place. That'll do it. let's plug that back in, test it, and then I'll do a little bit of wire management. Okay, we'll see if that clears. There's actually a decent little bit of space in there. I think it ought to. I'm optimistic. I'll probably route it something like this. All right, but first, before I get too excited, make sure that it works. It seems that often everything that you've got working electronically is prone to fail once you start getting mechanical connections tightened up. Okay, that looks good. Let's go back to the game. Yeah. Oh. Did I lose one? Oh, no, maybe it. No, that's working. Is this working? Good. That all works, and LED is lit. Good, good, good. All right. Put that out of the way. Okay, so I'm actually gonna hot glue this wire in place like this. For some extra strain relief, will that fit? That's pretty good right there. So that's a screw hole, a little boss for a screw. So if this gets pulled on, I've got slack and it's not yanking on the board connection. I used to hate hot glue. Have I mentioned this? I used to make fun of my friend, whoops, I used to make fun of my friend Joe Bowers because he used glittery hot glue on electronics projects. And now I'm sorry, I apologize, Joe. Now I like it. Partly because I got a high temperature gun that uses this high temperature, high strength glue. And it works really well for some things. It also comes off really easily with rubbing alcohol if you need to change your mind, which isn't the case with epoxy or a hole you've drilled. Hard to undrill. So let's also tape down, this was the masking tape that came inside of this thing originally, so I'll use that to tape down that wire, and I'll get some of my own. Just to keep these thin wires out of the way, but I don't feel the need to hot glue those. Good. These aren't used for anything anymore, but I'll leave them there in case I change my mind. That one I'm going to snip just so I don't short anything with it. That was that blue LED that I'm not using. Okay, those wires are, maybe I can just get them as I put them in. Let's see. Oh, am I too short? Some wire is too short there. Oh, drat. Let's see if I route that on top. Top of the USB.
Nope. Oh, man. All right, to extend this one, that's what I've got to do. Really? There's no way? There's no way. No, because that cuts across this whole... Oh, man. Okay, so emergency procedure here to do this. I'm just going to snip that in half and add a little bit of wire in the middle. Let's get some of this thin silicone wire. That's more than enough. Let's have that. All right, Noah and Pedro, again, this is for you. I'm going to test the... Yeah, Auto Stripper eats that 30 gauge stuff. So I got to use the precision dudes. And a little heat shrink is a good idea here. I don't have any super thin stuff here, do I? This will work. Wah, wah. I guess if I hadn't cut the resistor leads, I might have had the length I needed there. Well, that's a lot. That'll do it. Okay, so let's graft this into here. There are really cool guides out there for splicing wires to NASA specifications and stuff. I am not doing that. Oh, dude, I just yanked that off the LED. All right, that wasn't meant to be. So let's get a longer. Yeah, that the original wire's connection to the LED was super thin and tenuous, so I'll just extend the whole thing. Anyway, I was saying there's some great guides out there to splicing wire really well. I'm just using the twist it together method here to get that connected since I'm not going to the moon. So I'll do a little short bit on this end and tin it and then connect it to that LED. So let's get some helping hands. These are magnet ones, by the way, which I'm kind of digging. Since this workbench is steel, I can just magnet it there and it doesn't add another thing to the footprint. Okay. Things you can't plan for in a live broadcast include yanking wires out of LEDs and coming up too short on wire length. Oh, I didn't really need to tin that one, did I? All right. So let's get this one wrapped up, soldered, and heat shrink. Could you pretty much always regret when you don't heat shrink connections like that because you end up shorting something and being sad about it later. Okay, so let's tip this up so you can see it and I can see it. Anything to grab onto? sort of. Okay, so what I'll try here is just, since I tinned this wire, I'll try to see if that's enough solder to at least tack it onto that LED. Oh, you know what? I can tin that LED and there's enough showing. Okay. Pretty good. That should work. And now I should have enough wire to, yes. Okay, so it seems like that'll close now, and therefore it's time to hot glue this cable in place. Okay, sometimes you can, if you're impatient with hot glue, you can do a maneuver here to pick up a can of compressed air. You can cool it like that, or you can spray coldness on it if you flip it upside down. And that'll cool it a lot quicker. You can see it turns sort of an opaque color. It's very translucent when it comes out. It'll turn an opaque color as it cools, so you can, if you're impatient, you can get your hot glue to cool quicker that way. Yeah, it's pretty much cool now, and it'll stay. You don't always have to do that, and it's a bit of a waste of Freon or whatever they put in there, but it is one way to do it. All right, a couple more blobs here. Here. Here and here. And there. Okay, just enough to hold it in place. And I'm pretty sure the case itself and where this screw post is and the clearance will also do a really nice job of keeping this from moving. Now let's see if it really closes. It's promising. Am I forgetting anything? I hope not. Guess I should have tested it one more time. But what the heck? We're here now. All right, I'm plugged in. I've got, move this where you can see it. Red light, that's a good sign. Oh, what did plunger do? Oh, there he goes. Yes! And there is the theater of magic. So I guess it's appropriate, especially for the Twitch stream, if I just sit here and play this game for an hour. It could be a video game playthrough. Oh, you know what? I just noticed I might have to
do something different with this plunger. Yeah, watch this. Okay, I made a mistake. So I will just try to change this in software. So when the game restarts, you'll see that since that limit switch is pushed, it's already at that first of the two letters. I think it was XY or something like that. So it thinks that I've already drawn it back, and then when I go to draw it back, it lets it go. So that's inverted. So I'll need to watch the sort of invert, like high instead of low and low instead of high on that switch. So I won't probably do that in this live stream, because you know that it'll be a little bit painful to watch me muck around with the software to do that. But that's probably the last thing we need to have super awesome iPad controller running on, there you go, my iPad with the Duo Pinball controller. It wasn't made to do this. And that's all using the Teensy. Whoa, get up there. You can still tilt by touching the screen. Could be a kind of fun future mod to use like a vibration sensor or a few of them so that you can tilt by tapping this thing one way or the other. It doesn't use the iPad control, it seems. I might mess around with settings in the game to see if it does. Also, I'll need to lock this in a little bit. I got some wooden, just some little scraps of wood here that I can use to wedge this in a little better. So if that's wedged in nicely, because this was designed for a bigger iPad, if that's wedged in nicely, then you should be able to tap and nudge to get the behavior from the game. So those are all some future mods. Let's go ahead and, for now, screw things back together. And maybe come up with a solution for storing the cable in there. That could be kind of cool. So here's what I've got. Oops. My magnet full of screws here. But this is me saying I'm not going to fix anything with that button by going inside of it if I don't have to. I will instead try to fix that with software, and screwing it together is one way to ensure that. These all look to be the same length except for two. Those are probably these. So for $9, that's how much I paid for this little iPad controller. I'd say it's a worthwhile thing to pick up and play around with and hack into anything you want. Since it's got an LED and 3 switches, you could maybe use that IR distance sensor for something. I'll have one leftover screw because I didn't use 2 screws to put my proto board in there. The original Bluetooth-based board had 2 screw holes that fit the bosses in there. It's nice when you're left with one spare screw to know why. And here's the little rubber feet. We'll see if the original adhesive is strong enough that I don't have to replace that. Otherwise, I will try some good double stick tape. Okay, it's nice. It's got a good little grip. It stays put on there. And then, where'd the original battery door go? There it is. So to get that to fit over there, I want to be able to coil the wire in. You know what? That's more wire than it's going to fit in there. Okay, I'm going to ignore that. I think that's done. All right, let's plug it back in, and I'll head over to the chat and see if there's any questions.
And hopefully you weren't screaming at me, oh my God, your microphone stopped. But I do see a VU meter, so it looks like. All right. Oop. Sounds like a 3D print. Oh, for the door maybe? Yeah. Hot glue must have for all. Okay, let me switch over to this view. All right, is it Inception if I put the chat up here? No, you should be okay with that, right? Oh, it's a little Inception that my face is there twice. All right. NASA wiring standards. Yeah, Lyman Splice. Those things are awesome. If you haven't checked them out. Sean Reagan wrote a cool piece on that for Make Magazine a few years ago, I think. Let me see if I can pop that up. Is my keyboard up? Yeah. Make Magazine NASA wire splice. Let's see if that Google Foo works. Yeah, how to splice wire to NASA standards. There you go. So that's how you do it. Look at all that. There's a lot of contact there. And then you blob the entire thing in solder. Pretty cool. Need a guide on Adafruit for this. Oh, okay. Yeah, I think I could put together a guide. It's the specific controller is something that'll probably become harder and harder to find. So I could put a guide together that shows how to use this specific controller, basically redo this thing as a guide, maybe pull some images from the stream if they're high enough quality. And then you could generalize this to other types of controllers, or you can build them from scratch. I might do that too. That would be kind of fun to just do, like, here's a cardboard shoebox, a slit in it to kind of hold the iPad, and let's do 2 buttons, maybe 3 buttons. Do 2 for the flippers and 1 for the plunger. Not as cool as having the real springy plunger, but I looked into it, and there are, for people who build their own pinball arcades, pinball arcade, let's say digital plunger. So this thing here, $160 to get the plunger kit. So here's kind of what we have here from our $9 thing. Obviously, this is going to feel a lot nicer, but it's the plunger and some electronics, a lot of electronics that are measuring, I'm sure, measuring the velocity of this thing just like the original in this game did. So maybe if you're really into this thing looks super sturdy and nice, but I am very pleased with the $9 solution. Oh, that's interesting, Nova Piper. So that type of splice connection doesn't work as well for stranded wire? Interesting. I don't think I can make this piece any bigger while I'm logged in. All right. And is the animal org PETA? Huh? PETA, oh, pain in the... Ooh, ooh. Can't say the same for the deer. All right. Let me know if there were any other questions that I missed as we were going through, because I'm just scanning the chat here and I don't see any big issues or questions or suggestions. But if you do have suggestions on the build, please let me know. You can email me, jp@jpixel.net, or you can find me on Twitter, John Edgar Park, or shoot a question to us over with over on the forums or anywhere you like where you can find us, really. And we will try to address those in the little guide I'll put together for this. It looks like I've just committed to doing that guide. So that's all. I hope you enjoyed it, and we'll see you around. Later.